we present Entity-NeRF, detecting and removing moving entities in urban scenes. We tackled the problem of building a static NeRF with moving objects removed in urban scenes with a mixture of moving objects of various categories, large and small. Accurately rendering and reconstructing urban scenes plays a crucial role in many areas, including autonomous navigation, surveillance, and even virtual urban exploration. The challenges in reconstructing NeRF in urban scenes are diverse, including unbounded scenes, changing lighting conditions, large-scale data, and moving objects of various categories and scales. In our work, we focus on tackling the issue of moving objects of various categories and scales, a challenge that has not been resolved in existing research. Let's explore the challenges faced by existing NeRF methods in reconstructing dynamic scenes in urban environments. These methods broadly fall into two categories. One involves explicitly modeling the dynamics of the scene, and the other involves removing these dynamics from the training process. NeRFs that explicitly model scene dynamics find it challenging to learn these dynamics in urban scenes, where multiple moving objects exhibit complex motions. As a result, they struggle to accurately reconstruct both the moving objects and the stationary background. In urban settings where learning scene dynamics is problematic, one solution is to employ an approach that detects and then removes these dynamics from the training. There are two primary methods for excluding scene dynamics from the learning process: the knowledge-based approach and the statistical approach. First, the knowledge-based approach, which removes objects of a specified category by incorporating knowledge about moving objects, can consistently remove moving objects such as people and cars. However, it erroneously removes stationary objects from learning when they do not move consistently within the category. In this example, a stationary car parked in a parking lot would be removed from the training. Second, the statistical approach, which removes moving objects from learning based solely on the statistics of spatial residuals, is a versatile approach that can be applied to diverse scenes without needing prior knowledge about the scene. However, it mistakenly removes complex backgrounds that cannot be distinguished from moving objects based solely on residuals from the learning process. In contrast to these studies, our research considers the problem of label assignment, where labels indicating whether each entity moves or not are assigned using segmentation. For this purpose, we utilize entity segmentation aimed at segmenting all entities in an image without predicting semantic labels or instance labels. Entity segmentation can enhance the quality of segmentation by eliminating the need for class labels, enabling high-quality segmentation even in urban scenes. Our Entity-NeRF is a hybrid method that combines the advantages of the knowledge-based approach, which divides scenes into unlabeled entities through entity segmentation, with the advantages of the statistical approach, which determines whether an object is moving by averaging spatial residuals. Entity-NeRF consists of two technologies: entity-wise average of residual ranks, ER, which calculates the average residuals for each entity through entity segmentation, and stationary entity classification, which incorporates knowledge about consistently stationary backgrounds through thing-stuff segmentation. We propose entity-wise average of residual ranks, ER, a statistical process that makes determinations about whether an object is moving or not on an entity basis, rather than individual pixels or patches. By taking statistics of errors for each entity, ER ranks the residuals between rendered colors and observed colors, calculating the average of these residual ranks on an entity level. If this average is large, meaning there is consistently a large residual within the entity, it is considered a moving object and is excluded from learning. In contrast to robust NeRF, our entity-wise average of residual ranks, ER, has been shown to accurately detect nearly all moving objects without excessively excluding inliers. Therefore, our ER can more accurately exclude moving objects from training and include more background in training. In the early stages of training, all residuals are high, leading to low reliability of residual ranks and their statistical measures. We proposed the stationary entity classification to improve the weight assignment in the early stages of training. In this method, for entities of classes such as buildings, sky, and roads in urban scenes, which are certainly stationary, We attempt to assign a value of 1 to loss weights to ensure their inclusion in the learning process regardless of their residual ranks. First, we assign thing and stuff labels to each entity based on the thing and stuff labels defined in the Add20K dataset. The thing label corresponds to moving entities, while the stuff label corresponds to stationary entities. Furthermore, the thing-stuff segmentation is dynamically updated during NeRF training, allowing the inclusion of stationary people and cars in the training process. Our thing-stuff segmentation-based stationary entity classification provides more precise loss weights assignments for each entity than in initial learning stages, when all residuals are high. To evaluate our Entity-NeRF, a movie map dataset is created. This dataset consists of a set of perspective projection images extracted from 360-degree images sampled from 360-degree videos taken in urban scenes with moving objects. We annotated the masks of moving objects corresponding to these image sets. We trained a static NeRF with moving objects removed from these image and mask sets and rendered a static background-only images. These rendered background-only images are used for quantitative evaluation of the proposed method. We conducted a quantitative evaluation using the movie map dataset. As a result, our Entity-NeRF demonstrates consistent improvements compared to robust NeRF.